the panel was a very strategic and political thing. Where's the pointer? Is this the one? Yeah. I'm now talking about a little more technical things. In the last 2 days, I heard a lot about RO, reverse osmosis, and this is the process for desalination. It's of course one of the most important ones, but I want to introduce you to something. You heard about it already, of course, it's MED, but MED with MVR technology, meaning there's other options, alternatives, even to save energy, to do carbon emission reduction. And I want to introduce a little into the technology to understand what is there done to do the same things as an RO might be done. I'm Steffen Kuberczyk, it was correct, please pronounce, it's okay. The company is Pillar Blowers and Compressors. We are more than 110 years old. We're making blowers and compressors, as the name says. We are mostly in the mechanical vapor recompression blower technology. This is our bread and butter. We serve a lot of industries, we'll see that later on. The company is operating worldwide. We are based out of Germany. We have locations all over the world, 10 locations worldwide, 3 production locations, 1 in Germany, 1 in India, and 1 in China. So this is how we serve the world with our technologies. And we basically serve every aspect of the industries. You can see it here, we made more than 5,000, I think we're approaching 6,000 of these MVR units already. We started in the early 80s. We are, I would say, the technology leader for this. We produce about 600 blowers a year, that's a number. And one of the most important things, of course, as we will see that later on here as well, is that we match our machines exactly to the process that there is. We're talking about thermal separation, distillation, evaporation, whatever is there. So our units will then be served there as the blower for that process. And to show you how that works, I want to give an introduction to into evaporation with MVR. This is a basic picture of that. You can see on the left-hand side, it's a falling film evaporator. You have to think away the blower right now, because usually evaporation is done, is steam-driven. You have a feed, which would be right now the salt water. The salt water goes into the tubes. You heat it up with steam that comes in. The steam then evaporates the water out of the salt. The concentrate here would be the brine, the salty brine. Then the blue arrow is the steam that's too cold now, that goes out. You have to condensate it. Basically, you have to dissipate the energy into the environment. And then you have a condensate going out, which is then the vapor out of the system. This is basically what you've done when you do thermal separation. But if you want to look at energy savings, it's the left-hand side, this small diagram here. This is the saturated steam curve, it's the enthalpy over the pressure. And what you need to produce 1 kilogram of steam out of water is about 2,300 kilojoule per kilogram. This is water evaporating to steam. When you reuse the steam, which is a little colder than you need to be, you have a latent heat in there, there's still energy in there. And when you go to this side here, you can see this is the minimum energy you need then to get the steam back to that pressure, to the temperature you need for the process. And this is just a fraction of what you have done if you need to evaporate water. So in this case, there was a case, it's 50 to 80 kilojoule per kilogram. Depends a little on the inlet pressure, on the conditions, on the brine, on the feed that comes in, but it's only a fraction of that, what you need when you produce fresh steam out of water. For us we are the supplier of the blowers. We have a lot of process knowledge. We have process engineers working around, but we're not supplying the process itself. We can serve a wide range of applications, meaning our units start at 100 kg per hour up to 400,000, 400 tons per hour. I said it before, we customize our blowers for the processes exactly what they need. What we also do, very important of course to save energy, is that we try to get the highest efficiency of our blowers so that you don't waste the energy in moving the impellers, the propellers. So we're going up to 87%. It's very compact modular. We put a lot of efforts into that so that these machines will fit into existing plants in brownfield conditions so that we can upgrade those things. We have very low maintenance. It's still a blower. It's a fan. It's a blower. So the maintenance is very low. It's not a compressor like very high maintenance needed. And what we also can do is that we can put multiple blowers in series to achieve a higher temperature rise. Basically, you can multiply the temperature, what you want to get out of the system by the number of stages you have there. But now let's talk about the very topic of this presentation, is the seawater multi-effect distillation, MED, with MVR technology. This is, I guess, everybody hopefully knows that there's a three-effect MED. Again, forget about the blower. What you do is you feed steam, fresh steam, out of water into the first effect. The first effect then produces brine and distillate, of course. And the vapor, what I said before, is then going to the next effect. It's a little colder. You have 2 or 3 effects then, where you basically evaporate the water out of the seawater. The seawater is fed, is a little preheated, and then fed to every effect. And at the end of the day, you have a brine on the bottom, and of course the distilled water, whichever quality is coming out of there. Now, remembering the last before last slide, when you add an MVR blower, so in compressing system, you can take a bigger fraction of that vapor coming out of the system, compress it again, heat it up in energy, and you can reuse it as the vapor, as the incoming vapor for the system. That means you have basically a self-containing system, and the energy consumption is of course now electricity, but it's a fraction of that what a standard steam-driven multi-effect evaporator would need. Does work. So this is a small picture of a unit that's really simple. It was a project unit where you can see these are small units of ours. We call them vapor fan. They're basically man-high, these units. So you can see how small that this was, only for a few hundred kilograms of water. But basically, this is how a system looks like. That is only 2-effect evaporation. You get the steam out of the last of the second one. You compress it back again. You feed the water into it, and you have this multi-effect desalination with an MVR system. What we know, so it's again, I don't have any numbers about that, how deep it is, but I think multi-effect desalination with with MVR. When you take a look at the water quality, what gets out is basically in terms of kilowatts hours per ton, on the same level as RO. I don't know exactly what it is. But this is a unit that can run it. Of course, it's just, as you can see on top of it, of course it can be solar driven. This unit was solar powered also. So this is of course a possibility, because the electrical energy you need for the blowers is again a fraction of that, what you need for steam driven evaporation for the salt water. The key benefits, of course, I think everybody knows it. It's very important. I heard it from the panel before, all the other panels that were here in this very room, is that it's very energy efficient. You can reduce the energy by a lot, by a fraction to 1/8, 1/10 of the original energy. Multi-stage evaporation, this is not our business, but it's a very common thing to do. It's there. And of course, with that, the energy costs are very reduced to very low things. And again, it can be done with renewable energies as well. Now, the second thing, or the last thing I want to talk about is then the brine. What we never talked about, and I heard a lot of talkings about here as well, is the brine, zero liquid discharge. Basically, it's wastewater. Everybody calls it wastewater. It's not what we know. And what you can do now is the same thing. So you can use then a ZLD system. A ZLD system looks like this. Basically, here's an RO system in the front, but it doesn't matter. So you get some kind of brine, and what you can do now is brine concentration and crystallization afterwards. And same thing, these are thermal processes, and these thermal processes are steam driven, meaning you can use an MVR system as well. So meaning you can also use the waste steam or the waste vapor out of the concentrator or of the crystallizer, heat it up again, give it energy back, and then you can run the system on very low energy consumption. Meaning, this is again same thing, and at the end of the day, centrifuge necessary or not depends on what the brine is that comes into it. You have a solid waste, and yesterday I heard that there's a lot of things can be done with it. Basically, magnesia is one of the very important contents of the brine of salt water, so this can be done, and this can be also MVR driven as well. So there's also a lot of energy that can be saved in this process. Therefore, we have an example also. We did it with a partner of ours, Chem Process Systems out of India. And what you can see here was this was industrial wastewater treatment. But I think the last number, what you can see here, the COP, I think that's the interesting part of it, right? What was done here in terms of comparing it to a standard thermal separation, thermal process, it's only 1/12 of the energy. With what I said before, with what I explained before, with the mechanical vapor recompression, using the latent heat of the steam that's in there, compress it again, heat it up again, and use it as the fresh steam for the process. So that's only 1/12 of the energy that was used before, and we have, I don't know, 10, 12, 15 units of those, something like that, similar, different sizes in India already running. So when you take a look at this desalination, both is possible, of course, this desalination, the MED process with MVR technology, and if then needed and wanted, the ZLD, the brine concentration, can be done with an MVR process as well. So there's a lot of energy savings possible compared to the standard thermal processes that are now in business. Okay, of course, as ZLD, or the wastewater disposal is one of the things, so you don't want to have the brine getting into the sea or the effluents into the rivers. Of course, you can reduce the wastewater volume. That's one of the things. Freshwater scarcity, I think that was the panel, or the discussions were all about that. And the byproducts can be done as well. And again, compared to other things, also with thermal processes, facilitating or utilizing MVR technology. Okay, I'm done with my presentation. I hope there was some insights for you for that. If not, we have a booth outside here. You can still have questions for us, and we can talk about details of this process if you want to. Thank you very much.